the next step is we'd like to go through and sort of do a quick and rough building rating together just to show how the process works. And then we'll have a good amount of time for questions after that. So in terms of the rating process, not the rating process, but the certification process, and specifically the P58 training portion, there's three pieces to it. There's the overview webinar today. We have 36 that were signed up for this time today, and about 10 more that couldn't make this morning. So we will be creating YouTube videos of the presentation today, both for the people that couldn't make it and also for reference. If you want to go back and, look at an aspect of something, if you want to review things later as well. And then we'll go through and have each participant do an example building rating. And we've set up a 2-week trial account for the SP3 software. That's complimentary to support that aspect of the training. And you should have received an email, I believe yesterday, from the SP3 system, and then a confirmation email from Katie Fitzgerald that says that your account is set up. If you didn't receive that, check your spam filter. It should come from support@SP3, and that has your login credentials in order to get into the SP3 system and use it. If your company is a license holder, you can use that new account we created, or you can use your own account. It's up to you in terms of where you want to create your model. So once the rating sort of draft is done, the objective is hopefully to get into it and at least get to the point that you'll have questions by next week. And then we have the Q&A sessions set up next Tuesday and Wednesday. So those are 4 different hour-and-a-half sessions. You can pick one or more if you like, but probably one. And you can bring questions back to those sessions. So if you try and do the rating this week to be able to have questions for next week, we can handle questions then, and then hopefully complete the example soon thereafter. And then once that's done, if you want to email that to Ron, CC to me, do you want to do it that way, Ron, or do you want people to have it emailed to read, or how do you want to handle that? In terms of an email confirming that the example rating is done and can sort of be checked off the list. Let's see. I may have
unmuted.
There we go.
Yeah. Have it sent to me with a CC to you.
Okay, sounds good. And then we'll keep track. So the purpose of the example today is really to kickstart this process. So we'll go through the software, explain how it works, and the purpose of the software is frankly to implement P58, the supporting stuff for the USRC, and make it usable in practice. So it's crafted exactly for what we've been talking about so far on the call today. So in terms of steps of the analysis process, just to give an overview of how the software works, the software is web deployed. It runs on Amazon Web Services, and it stitches together each of these steps in the process. So on the hazard and ground motion side, the soil information and the ground motion hazard from USGS is embedded in the system, so it'll grab those things automatically. You can overwrite them if you want, if you have additional information. The simplified structural response method is also embedded in the system, so you don't have to do a separate calculation of that. The system does it for you based on the inputs of the method. You, of course, can input your response history results as well. In terms of building contents, the normative quantity information from P58 is implemented into the software so that it'll pre-populate expected quantities. You can then go and override things as much as you want, right? So it doesn't take any control away from you in terms of how detailed you want to go. The P58 document doesn't give feedback on expected structural components. So we also have a structural component auto-population algorithm that asks you questions about base spacing and number of frame lines and things like that, general sizes of components. And then it pops populates those for you as well, so that you don't have to go through and manually input those. But again, you can manually input anything you want if you want to go beyond the defaults. In terms of the structure, it's really set up to be two-level, right? So there's default quantities for almost all of the inputs, based on what structural system you select, based on what design category you're in, based on the age of your building, and so on. And those are meant to sort of get you in the ballpark quickly. And what we'll do what we'll do today is go through and use most of those pre-populated values to get in the ballpark, right? And then the idea would be, once you're in the ballpark, then you can refine steps of the analysis method, refine your contents, just refine various aspects in order to then get to your final analysis that you'll then use for your rating. So all of the things are overridable. So like I mentioned, it's web deployed. It has features, creating PDF reports, things like that. We're also setting up a review mode to help facilitate the review aspect of the USRC process, so that a reviewer of a rating doesn't have to review a 100-page PDF. They can go in and actually review things in the system and have things marked up to show where defaults were overwritten and so on. So that's something in progress as well. So I'd like to now go and switch over to the system, and we can just go through and do a demo together. I'm thinking to do this relatively slowly and systematically. I think we'll do questions at the end, but I think that we can step back through the system, with the various steps of it, and ask for specific questions about each step at the end, so we can have sort of a structured Q&A at the end. So the system is web deployed. So you'll go here and log in with your login credentials. So email and password, which you've gotten by email. And these are lots of different accounts. I'm going to go into the P58 training account, which is the one that you've been set up for. There's a couple of examples in there already, just to get you started. There's a set of 3 different building examples at an LA site, 4, 8, and 12-story new concrete frame. So you can go through it and look at those and see, how those are done, just to help get you started. In terms of training on this, we also have an SP3 University page that has tutorials for a bunch of the aspects. So overview, how to do a USRC analysis, how to do hazard, and, building capacities, building components, ready downtime, and so on. So beyond the overview, it has specifics about sort of each step in the process, so you can refer to that as well if you have questions. Or again, we can do the Q&A, of course, next week. So in terms of the structure of this, it's set up as sort of projects and models. So a project is a site location. So this is a project. And then at that site location, this LA site, which has a specific address, latitude, longitude, I have 3 buildings. I could actually have 3 buildings on that site. It could be various design alternatives I'm looking at. It could be retrofit alternatives. So you'll end up probably having many of these models per site because you're testing and tweaking and playing with things. So in terms of setting it up, let's go to create new project. And a project is just the site location, right? And then once you set the site location, then you create models, right, of various buildings or designs or whatever at the site location. So let's call this, let's do Stanford project. You can put in client information for your own tracking here. Right, we're going to use A1 Insurance Group just because that's a little default that we put in there. You can set permissions sort of on, whether your site information is confidential or not, and this will be tracked through to reports, and also, review mode information that gets sent to reviewers if you choose to use the review mode in the future. So let's do building on Stanford campus. And then you can type in address if you want. or you can just go to the map and, I don't know, let's put it somewhere. Let's design it by the Hoover Tower, right? So you can put an address and so on, type it in, or just drag and drop where it is. So let's stick it there just for fun, and then save project. Save project. Okay, so at this point, project is set up. It just knows where you're working at. It knows what the location is. And then the next step is to set up a model. So let's set up a model of a building here. Now, this takes you through the whole theme of P58 process. And how it's structured is you have each step in the process up here. So overview, analysis options, hazard, response, building capacities, that's collapse residual, components, and then output results. So you can go through and use next buttons to progress through this, or you can skip ahead and look at things later. But it'll tell you, hey, you need to give me more information before I can go there sometimes. So let's start with the overview. So let's do, I don't know, let's pick a 12-story RC frame. You can put, reference numbers and notes and things in here for your own bookkeeping. So the reinforced concrete perimeter moment frame, concrete perimeter moment frame. You can do different structural systems in the two directions. Design year, let's call this a new building. Number of stories, I think we said 12. Let's do 12-story. Total building square footage, I don't know, let's pick 250,000. You've got cost per square foot, which is default based on building size and occupancy. You can override it if you want. All of this is structured such that any default you can override. Number of stories, 12, story height 13, commercial office, risk category 1 and 2. Throughout the system, there's some advanced options tabs. So down here, there's more specifics on building dimension. So it assumes square. Let's override that and say it's not square. It has information about default building replacement times and so on. Most of these things you won't override other than the building dimension, right? So you'll, put approximate building dimension there. Also, as you go through the system, there's little eyes, right? Little information boxes. So those explain what's happening, right? So cost per square foot, right? Present dollars, default cost value based on national averages, and based on present date and project location. So, these are default values based on basically where you're at, what size building you have, and what occupancy you have. Okay, so now we have the basics of the model set up, right? We know the structural systems in each direction, design year, square footage, number of stories, occupancy, risk category, all that kind of stuff. So let's go on to the next page. So the next page is analysis options. So what analysis do we want to do? In P58, there's 3 options. There's intensity-based assessment, time-based assessment, and scenario. We've implemented intensity and time so far. Let's run both of those. Scenario is not implemented yet. USRC analysis, we want to do all 3 of those. I need to remove the beta here because it's not beta anymore. It's complete, so I need to remove that. And then also we have the ASC 3141 rating checklists supported in here. So let's turn that on just to look at that. And we're also creating a free tier of SP3 that'll be ready in a couple weeks that will allow people to do the 3141 checklist without purchasing a commercial SP3 license, just as an aside. Other analyses, ready, repair time, and downtime. We need to run those for the USRC, so we'll keep those checked. And then how many realizations do I want to run? And this is how many times I can run Monte Carlo. So this gives some basic information. Minimum number required for USRC is 2,000, so that's what we have in there. Maximum that we recommend is 10,000. That's probably an overkill. Let's go a little bit above just for fun. Let's say we want to run 3,000 realizations. Next page. Okay, so here's the ASC 3141 checklist, and this is really sort of an aside, right? You don't need this for the P58 rating process, but it's in here if you want to do either do a comparison to the checklist, or if you want to, again, once the free tier's there, if you want to use the checklist for your rating. So select building type, concrete frame, say life safety, let's just say, high seismicity, and then the checklists are based on those. So you gather all the checklists in the 3141 process. So you would go through and answer yes and no for various things, right? Notice that the things are dynamic. So let's put those there so we see everything. Depending on what you pick up here, then you see different checklists. So you go through and finish the checklists, and it dynamically, again, since I didn't fill out the first stuff, it gives a whole lot of things. So then it dynamically gives you your rating, right? Since everything's unknown, right, it has 1 star for everything, but as you complete the checklist, then it'll dynamically give you your 3141 rating here at the bottom. So that's just a sort of FYI aside. Let's go back to analysis options, and we don't need that here, so let's just move on. So next step, you can navigate here or navigate here. Let's go to the ready process. So for the ready process, we've got the documentation for ready embedded here that you can download. So you need to include things about impeding factors. So let's say inspection, yes, you're going to need inspection. Financing, let's say that Stanford is self-financed, so they're not going to need to go out and get a loan. Permitting, sure. Mobilization of engineer and contractor, yes. Is the building essential facility? No. Is an engineer on retainer? Let's say yes, they have an engineer on retainer. Right? Post-earthquake review arrangements, yes. Contract on retainer, yes. So you answer these questions, and it affects your impeding factors and the amount of time it takes in that first step of the recovery process before any of the repairs take place. Down here, these are all the defaults. We probably should put these under an advanced options. The expectation is that you wouldn't be modifying any of these, that basically the user input would pretty much stop here and not go beyond the worker allocations. But again, the basic philosophy of the system is include defaults, give the engineer complete authority to override defaults, right? Don't pigeonhole them into something by the defaults. So that's why they're here. You can go through and override things if you really want to dig deep in the process. So next page. Okay, so next up is hazard. So you can either put in your user defined or use USGS. So if you want your user defined, it grabs soil stuff just for comparison for you, but you just upload a CSV file. There's an example here of what the format would be, or you can go through and actually just put in the numbers, right, and put them in manually as well. Let's use USGS. It automatically went and said that we think it's site class C based on the site location. You can override that. So let's say, well, actually, I think it's D, right, just for fun. We also have to decide what period we want to do the hazard analysis at. And here's some period suggestions, right? So a HAZUS period, what's called a building period. So this is like a CHOPA period. These two periods include the effects of non-structural components in the period estimate. And then we have an estimate of the bare structure period as well. And that would be an estimate of what the period of the building would be expected to be for this 12-story building, just if you did a bare frame structural model, right? But again, for loss assessment, it would be conservative to use that 2.5-second period because you would be overestimating the drifts because there are non-structural things there. So for simplicity, let's use the 1.67. Let's use the HAZUS period. Note that some of the ongoing development that we're doing on the ATC 58 Phase 2 project is to more directly account for non-structural effects. So right now you have to specify what you think your effective period will be based on your ground motion shaking level. But we're working on making that basically dynamic, where you would start with a stiff period and then end with a more flexible period at a large ground motion level. So we'll use the HASIS because that should be, approximate thing that, relates well to a Chopra-like period estimate as well. Compute hazards based on that period and soil and site location. So when you hit compute hazards, what it does is it goes to the USGS online databases and grabs all the hazard information, right, for your site. So it grabs a whole bunch of hazard levels, right? So you've got exceedance probability, the SA level, PGA, return period, and so on. You then select here which ones you want to run the analysis at, right? So we've got 10 and 50. That has to be selected, right, because we're doing a USRC rating. It has to be there. You can also pick, I want to do some low-level runs too, right? Maybe I want, you just pick which ones you want to do the runs at, and then it'll track through the results for each. Plots the hazard curve, same information above. It also gives reference ASC 7 values, and this is primarily for comparison, just for a sanity check in terms of, for your engineering judgment to make sure that things look right. It does pull seismic design category, which does affect the pre-populations. So if you're a new building in design category DE, so on, it'll use different components than if you're a new building in design category B, or if you're an old building in a high seismic category. So it does affect that, but primarily these are just for comparison. And then we put a bunch of maps here just for fun and for presentation in terms of faults and so on. So you can hot link, takes a second for it to load, but this comes from USGS databases as well, so you can go and get information about the faults and so on. We embed Alquist-Priola zones, liquefaction zones, liquefaction susceptibility, and then tsunami inundation. So let's see, some of these are available statewide, and some of them are just currently for the San Francisco Bay Area, right? Because the databases differ by location in terms of being available. And that's, again, for reporting and just for understanding. We also include de-aggregation in terms of, which faults contribute, how far away they are, and so on. So if you can use that for, your risk assessment report, or just for your own understanding. And the basic de-aggregation images from USGS are automatically loaded. And you can change it, so 10 and 50, I want de-aggregation for 2 and 50 instead. So it takes a second because it goes and grabs a pretty big amount of information from the USGS server as it does this. There we go. Okay, so we're done now with site hazard. Okay, so we have our ground motion hazard curve. We have soil information that went into that and so on. Next step of the process is structural response. So again, multiple methods for it. Let's start with user input response history. So if I want to use response history, I just need to upload my response history results, right? So there's an example CSV file that shows what that should look like. And then you upload that CSV file, and then it comes into the system, plots it, uses it, and so on. And then also there's a modeling uncertainty beta that you have to include, which is explained here in the P58 process. The other options are the simplified method from P58. We have a simplified method extended for weak stories that gives you a little bit more, and that's a beta version. We're working on that more. That gives you the ability to say what stories the inelastic deformation concentrates in, rather than just making a complete regular building assumption. And then we put a couple coming soon things here just because those are very near term, so you'll see that they're coming. User input response. That's if you do a response spectrum analysis or something to get drifts and accelerations, you can then input those. And then also estimate for shear walls for the shear wall chord rotation and coupling beam rotation. So currently, if you do a shear wall building and tag the shear wall damage to gross story drift, it'll over-predict the damage to your shear wall. So you can do that to get a conservative estimate, but it's a pretty large over-prediction in terms of the structural damage to your shear wall. So both of these we're working on now, and we're hoping to get those done by next week for the Q&A. So if anyone has questions about those, we can handle those on the Q&A as well, if you're looking at a shear wall building or if you want to use response spectrum analysis for a comparison. Okay, so let's jump into the simplified method, and let's use that for sort of our, quick and dirty, if you will, that we're doing for this illustration. So in terms of inputs for the simplified method, there's basically 4 inputs that you need. The simplified method, you need building period, you need building yield base shear coefficient, and you need yield story drift. So again, we have the period suggestions for Hases, building, bare structure. So for our building period, let's use the Hases period. And then the yield base shear coefficient, this is a default value based on building type, building height, and so on, and risk category, and so on. If you want to do a more detailed calculation, you can override that. It doesn't have a huge effect on the simplified method results. The period has a much larger effect. And then yield story drift, that is used for the residual drift calculations in the P58 simplified method. And we're using a default of 0.75% for a concrete frame. And again, you can override any of these values if you like. And then the other input value is mode shape, right? So we use a default mode shape. Again, you can have different in 2 directions. We start with the default mode shape from research by Eduardo Miranda, and that default mode shape changes by building type. So this is the default mode shape for frame type building. If you want to dig deep into that, you can go into the advanced options and, change the, mass ratios and alphas and A's and all the things that are used in the, to create that mode shape. And they're explained here. But I would say in most cases, you're either going to use the default mode shape, or if you have an analysis and have a mode shape, then you would just override that and put your mode shape in. And we did have a request from one user for a little CSV upload here for the mode shape, which we'll be working on as well. So for the simplified method, once you have those 4 inputs, building period, building base shear coefficient, yield, yield drift, and mode shape, then that's everything you need to do the response estimate. So you go here and click compute structural responses. It gives you a flag. Right, I ran these up to, I think, a 2 and 50. So it says that strength ratio above 4 happened. So note that this is outside of the recommended bounds of what the simplified method should be used for. So as a reminder that it's not supposed to be for crazy nonlinear response. So then it goes out here and gives story drifts, right? So story drifts for all the ground motion levels, 5 and 30 up to 2 and 50. For the various ground motion levels, various stories. Peak floor accelerations. You'll notice that if you're at low levels of ground motion, right, it's like this. If you're at high levels of ground motion, it de-amplifies based on how much the building has been yielded, right? So you see that the peak ground acceleration, marches up systematically, but then when you get up to the high levels of motion when it yields, then the actual accelerations that get into the building are saturated in the simplified method. And again, all these are direction 1 and 2 if you have different properties of the building in the 2 directions. And then here's residual drift. So no residual drift up to intensity 4, and then we start getting a little bit. And then that will be used for, estimating whether the building will be torn down with residual drift and so on. in the process if you include residual drift in the process. Okay, so we're done with structural responses. So now let's go into building capacities. Now, building capacities, if anybody has a better name for this, I'm all ears. It's sort of a catch-all for the collapse capacity of the building and the residual drift. So let's start with residual drift. Just for fun, let's include it in the analysis. And these are the default residual drift capacities that P58 specifies. So what this is saying is that on average, if you see a residual drift of 1%, half the time you'll demolish the building based on that residual drift, and half the time you won't. And then, of course, there's variability about that. So you can, again, override those. You can use the defaults at any step of the process. You can tweak and override things. Collapse capacity, there's a few options of estimating that. You can first off not include it in the analysis. You can use the FEMA 154 checklist. You can put in a probability of collapse at the NCE, but note that it says not available for USRC analysis, so it won't let you click that. And also user-defined collapse won't let you click that either, because we've said that we're doing USRC analysis, so the FEMA 154 checklist is a required component of that. So let's go there and view the checklist. So I can do a level 1 or 1 and 2 screening. The USRC says to do 1 and 2. These are some basic things about seismicity level, basic scores for the building type and soil type and risk category. And then you go through and answer all the questions. Sloping site, weak soft story, so on. Let's just skim through this. Let's leave no for everything. Base isolation, no. Pre-code, no. Post-benchmark, yes. We get a 2.4, which is a good score, which basically tells us that our collapse capacity is fairly low. So let's save that. So then that populates the probability of collapse beta in the collapse distribution. And that's use of that checklist is an integral part of the USRC process. And then collapse modes, if you want to really get crazy, you can say that I have 20% chance of pancake and 30% chance of one-story collapsing, and if you really want to get crazy about the P58 process, and then fatalities and injuries in terms of rates. And these are default rates for the building type. So these are default rates for a concrete frame, but again, they're overridable if you really want to dig deep. Okay, so next step is building components. So now we have to specify what's in our building, both non-structural and structural. So there's 3 tabs here. There's components, there's fragility manager and fragility editor. Let's go to the fragility manager just to show you can search for a fragility here. Let's say I want to interior construction partitions. Let's say I want to full height with metal studs. Okay, yeah, that's the partition that I like. Right, all the pictures of damage states, view fragility details. If I want to get really crazy about it, I could go through and look at all of the medians and betas for every damage state and so on. So there's a lot there, so it goes on for a long time. If I want to get really crazy, I can unlock the fragility and modify it and make a user-defined fragility that's a modification of this fragility, or I can create my own fragility. Okay, so back to the fragility manager. That's the one I like, add fragility, and that comes into the list here. So I say that I have quantity 10. I have that at every story of the building. You can go through and do different quantities for different stories. I have it in both directions, right? You can put it in direction 1 or 2 only, or 1 and 2. And the demand parameter for wall partitions is story drift. That's what drives the damage there, so we're using story drift. So if you want to go through and manually put all this stuff in, that's what you would do. Or if you want to kind of modify things, you would go to the fragility manager, select it, and add it. We're not going to do that because that would take forever to do. So we're going to go to auto-populate components. And we have 3 options. We can auto-populate just non-structural. We can auto-populate just structural, or we can auto-populate both. So let's auto-populate both. So what it does is it asks us questions here, right, about what types of curtain walls and partitions, and then about the structure and so on. There's really not a lot of questions that it's asking here, right? It just says what, curtain walls, let's say glass, right? Partitions, metal studs, it's full height with slip tracks, let's say, right? Or friction, slip tracks. So it doesn't ask a whole lot. It asks about slab, PT slab. Does your gravity column have shear reinforcing? Yes. What's your shear ratio for your slab? So on. It's not asking much because this is a new building. So if we go back to the overview page and we instead say that this is a 1925 building, okay, so let's do that just to see the difference. I go back to the components, and now I auto-populate contents for a 1925 building. It's going to ask a lot, right? If you have roof tiles, are they secured? Right? Do the stairs have seismic joints? Are your ceilings supported? Is your lighting seismically rated? Is your piping rated? Is your HVAC anchored? And so on. It's going to ask a lot more information. So since you have a new building in design category D, it doesn't do that because it knows that you need those things for a new building in design category D. So let's go back to that, 2015, and again do it for our 2016. So let's say monolithic glass, metal stud partition walls, full height slip track, PT flat slab, shear reinforcing yes, and let's say high shear ratio. And then for structural direction, right, here's again information boxes for explanation. What's my typical bay length? Let's call it 20. We could go and say, well, in this direction it's 30. Total number of bays in this direction, let's say 8. Let's take this down. I'm just making up numbers. 6. I'm not calculating these in detail. Number of separate frames, perimeter, so 2 frames in that direction. And then total number of bays, 15. How are the frames detailed? Special detailing. Do they have weak joints? No. What's my column size? I don't know. Let's pick 36 by 36. And then same thing in direction 2. Special moment frame, no weak joints, 36 by 36, or we can pick a different one just for fun. Okay, so now once we answer these questions, when we hit save, what it'll do is it goes back and uses the normative quantity information from P58, but also uses information about your building, because the normative quantity information just says you have a certain number of square feet of, let's say, ceilings, but it doesn't say which ceiling fragility to use. What design category is it, right? What's the level of anchorage or, bracing, so on. So it uses the normative quantity information, but also information about design date and building location, particularly design category, plus all of these answers that you gave in order to estimate what's in your building. So it went through and it put in slab column connections. It put in all the beam column joints, exterior and interior, right? So you'll see here there's 4 of them that have a beam on one side and 13 of them that have a beam on both sides, and so on. If you want to modify things, you can go here and say, okay, well, actually, my RC slab column connections, I want to copy that one, right? There's delete and copy. There's also expand if you want to look at the detail. I want to copy that one, and at all the stories except for the first 2, right, I have that number, but actually the footprint of my building for the first 2 is a little different. So let's say I have 45 there, just making stuff up again. So you can easily, copy and change the quantities per level and so on. So these are structural components. Then you have non-structural components, curtain walls, partitions, suspended ceiling, traction elevator, piping, just all of the things in the building. And then we have a category down here that's non-structural components with user-defined capacities. So based on since this is a new building, right, we would be doing ASC Chapter 13 kind of calculations for anchorage of things like chiller, cooling tower, air handling unit, and so on. We also might be doing calculations of, stairs with a seismic joint and how big that joint would be. So rather than having the user have to go out and do all those calculations manually, we have the Chapter 13 content embedded. So right now it does the Chapter 13 calculations. There's some inputs here, design displacement, importance factor, recommended additional drift capacity that you design for to make sure the gap's big enough, and so on, kind of what your implicit factor safety might be. So you can modify some of these inputs. If you look, like, for example, cooling tower, importance factor, response modification factor, and so on. So you can modify those things in order to modify the Chapter 13 calculation. Right now it's set up just with the Chapter 13 calculation. We also intend to put a few input fields where you might say, well, I think I might have half the capacity of Chapter 13 or 0.75 the capacity of Chapter 13 or something like that. Right now you can override those capacities manually once they're calculated, but we're planning to automate that a little more so that you can exert some judgment there in terms of older non-code compliant buildings and what non-structural capacities you think that those will have with anchorages and so on. So you then hit compute user-defined non-structural capacities. All right, proceed. We're going to overwrite things. Yes. So now it goes through and does a bunch of calculations. And now, for example, we have a whole bunch of low voltage switchgears, right? Because the capacities of those vary by location in the building. If we wanted to simplify that, we can say, well, actually, we would design, the top 4 stories to have the roof capacity, so you can delete 9 through 11 and just set this one. Let's just do that for fun. Set this capacity at 9, 10, and 11, and then delete 11, 10, and 9, right? So you can simplify it if you'd like in terms of, steps of how you would actually do the design and not do it per story. It also chiller, cooling tower, so on. It does all the calculations for those things based on Chapter 13. Again, if you want to add fragility yourself, you can do those things manually as well. So once you have all of your building components in there, right, now that's the end of the process. So now we go to output results. This hasn't been run yet, so let's run the analysis. It goes and starts to run on the system, on the Amazon Web Services, and it shows this processing. So it'll probably take a few minutes to run. So while we're waiting, let's go and look at the results for this one here. Right, I set this one up to look at some of the results. So this is an 8-story at an LA site, but just to show the results, let's show what that looks like. So go to output results. We have a bunch of outputs here, right? Expected annual loss, right? We aren't focused on that, so I'll sort of skim over that. But it gives a breakdown of expected annual loss, where it comes from. Most of it comes, let's see, in this case, we've got structural, but then also partitions and interior finishes. I must have used less damageable partitions in this example or something. But it shows the breakdown. And then repair cost, intensity-based results. So what this does is it gives results for each level of ground motion that you did the analysis at. In our case, we care about 10 and 50. So for this example, it's 11% damage at the 10 and 50 on average. It also gives a median and 90th percentile. Shows a plot of mean loss and 90th percentile loss and how that grows over ground motion intensity level. Shows the breakdown for where loss comes from. And then a table showing the breakdown numerically. And then also, it'll show graphics of most damaged components. So for this building, 8-story concrete frame in LA, at the 10 and 50, the most problematic structural component is actually the gravity slab column connections, the PT flat slabs. And it's only damage state 1 though. They replicate this picture, it looks worse than it really is, right? And it gives the average loss to these components for a 10 and 50. For non-structural, it's the wall partitions, and on average, those are in damage state 1 for a 10 and 50. You can go up to a 2 and 50, and we have a worst case damage state 2, for the slab column connections at a 2 and 50. And then the non-structural component that's worst case actually changes. So at a 2 and 50, it's the curtain walls that have more damage to them. And it says, glass falls from frame. This is on average, but that's at a damage state 2. And there's a lot of curtain wall options, right? So you'll want to modify your fragility input or your content input to reflect the curtain wall type system that's on your building, because there's many different ways, obviously, that you can do curtain walls. But this helps interrogate the results, and you can use the results for grabbing the image and communication and so on. Okay, so then repair time. We have the P58 parallel and series times. We have the ready times, reoccupancy, functional recovery, full recovery. We need to remove the betas from these because those are done too. So if you look at 10 and 50, it would say 148 days for reoccupancy, 152 for functional, 175 for full. Gives plots of them. Median values if you want median. And then also downtime, including impeding factors. So in this case, I think I had a lot of the impeding factors turned on in this example. So the downtime with impeding factors was high. So then casualties, fatalities, and injuries. Right, we've got injuries non-collapse, injuries due to collapse, fatalities due to non-collapse, fatalities due to collapse, and then totals, and then plots of those. We also have building population information here, right? Because if I say that there's 2 injuries from expected at a 10 and 50, this gives context for the mean population at any point in time over a 24-hour period and by month and so on, and then the maximum population that would be expected in that building, so that you can normalize and get a sense for what injury rate that is. And then USRC ratings, right? So this building got 3 and 3 and 3, code compliant building, makes sense. So then it gives the descriptions and so on here, some information boxes and so on with more detail. Shows that we got a 3, and then shows some very detailed information here about injury probability, fatality probability, and all those things that were used in the above calculation to meet the USRC requirements. Repair cost, again, 3-star. Repair cost is 11% in this case. Time to regain basic function. Let's see, it has selected 2 there, but shows 3 up here. Odd. Okay, well, I will talk to my programmer about that. Looks like a little bug. So this is an older model, so it may not have been updated. So, but anyways, gives you explanation of time to regain basic function, how long it takes with impeding factors, and so on. And then if you want to go really crazy, right, you can download all sorts of information from the P58 process. Summaries of repair time, casualties, most damaged component, expected annual loss, time, repair time, building contents, USRC detailed results, comparisons for different repair times, what the simplified method EDPs were. There's just a whole bunch of stuff you can download if you'd like. And then generating the PDF report, we have that done. But we need to do some more work on that, so we've taken that one offline as we work on some of the content of the PDF report generator. Okay, so let's go back to our project page, and let's see, the 12-story that we ran, so it's done. So let's view the results. All right, so same results. Let's go to ratings. This one's a 232. We can look at where that came from in terms of what caused those ratings for this building. and then look at the results if we like.